Another fantastic constraint modifier that we have access to inside of the moto rigging system is the direction modifier. And for this one, I think what we're going to do is deactivate the visibility of my little target and focus primarily on the big target and my little arrow. Let's draw this arrow out a little bit, just so it's a little easier to see precisely what the direction modifier is going to do. Now, if you start to extrapolate, you can probably guess exactly what the direction modifier's role is inside of the moto rigging system. If the position modifier matches the position of the two connected center points, and if the rotation modifier, the rotation constraint matches the rotation values of the two constrained elements, well, the direction constraint is going to have the center point of the child object match the center point's direction of the parent. Let me show you what I'm talking about. I want to have my little arrow here point automatically at my ring and always point at my ring. So let's just do it and grab my arrow first, hold down the shift key, grab my big target, go back over here to my modifiers, and then fire off the direction. Now you're probably wondering, Pat, this is interesting. My arrow flipped around, but let's do some analysis, and specifically, let's look at the center points and the orientation of the center points within inside the scene. If you notice, my arrow is actually facing a very defined different direction. It was facing to the left a moment ago, and let me go back in time just so you guys can see it. There we go. Or excuse me, it was facing to the right. It's local left, but here we go. It's facing this way, and then after I made the direction modifier, it flipped around. Why? Well, let's take a look at here, and the answer lies in the orientation of the center points inside of the connection here. Look at the center point for my arrow. There it is right there. Now look at the center point over here on the big target. What's going on in this modifier is that the center points are now looking at each other, and a specific positive side of an axis is looking at another specific positive side of another axis. So the positive values of the z-axis on my arrow are always looking at the positive z-axis of the parent itself, and this is the result that we're getting at. It flipped the arrow around because before I made the constraint, the positive orientation of my arrow was the other way around. Now, we need to make some changes because I would much rather have the tip of my arrow facing the center of the ring. Well, luckily for us, making this change to the connected items is really easy if we go into the actual direction constraint itself. And check it out. Here's one of the properties that we have. It's the axis. Well, I don't want to have my arrow's local z point at the center point of my big ring. I want maybe it's X, because look, the X axis is facing towards the tip of the arrow. So let's make that change real fast. We'll go over here to the constraint modifier, and we'll change the axis to X, and there it is. Wonderful. I like this a lot, because now, check it out. If I zoom out, grab my big guy here, fire off item transform, anywhere this blue guy goes, the arrow is always going to point at the center point of that location. Now, it's always going to do the center point. It's not going to do anything else. Remember, when we're working with constraints, it's center point to center point. That's all we're really influencing here. But you can see the value of this direction modifier. This arrow's center point is always going to be faced towards the center point of its connected element, which is also pretty neat. Now, in addition to being able to change the axis inside of our constraint, we can also do a negative axis, so we can flip it around a little bit. We can also give it a roll value here, which is kind of cool, and it's really important to note that this is a value that we can animate, which is also pretty neat. Now, this up vector stuff, we're going to talk about this a little bit later. It's kind of advanced, but this is going to be able to help us define where which direction the y-axis and our center points are going to go. So if you look at it, right now, the local orientation of the y-axis is influencing our arrow. Well, we can assign an up vector to ensure that the local orientation of the y-axis rotates to always match the global orientation of the y-axis. Again, more on that later. But the directional constraint is a handy-dandy one to have in our tool set because it allows us to ensure that two elements are always facing each other, or one element, the child object, is always facing the parent. It's a handy-dandy one to have in our toolbox, and one that I know you'll use going forward.